All right, let's begin with the class. Inshallah, we are going to resume trigonometry. We'll try to do as much as possible. अच्छा, लास्ट क्लास में हमने जो किया था थोड़ा सा मैं उसको रिकॉल करवा देता हूँ ताकि जो है वो हम वापस फ्लो में आ जाएं, क्योंकि कुछ टाइम गुजर गया क्लास को लिए। तो क्या क्या हमने किया है थोड़ा सा हम इसको देखते हैं इंशाल्लाह, और फिर क्विकली हम 5 मिनट में रिकैप करके आगे बढ़ते हैं। तो फर्स्टली इन ट्रिग्नोमेट्री वी स्टडीड रेसिप्रोकल ट्रिग्नोमेट्रिक फंक्शंस. There are three functions that we have already studied in AS: sine, cos, and tan. And in A2 level, in P3, we have studied three more trigonometric functions, which are the reciprocal functions of the function that we studied in AS, right? So reciprocal of cos x, 1 over cos x is equals to sec x, cosec x is equals to 1 over sine x, cot x is equals to 1 over tan x, but they all are defined. Sec x is 1 over cos x, but cos x should not be equal to 0. Similarly, cosec equals 1 over sine x, but sine x should not be equal to 0. We discussed in detail, right? Then cot x is 1 over tan x should not be equal to 0. फिर मैंने कहा था याद कैसे रखना है, how to remember. For remembrance, I said that you need to remember the third letter. So sec is basically ending on a C. So it's the reciprocal of cos. Cosec, the third, sorry, sec, the third letter is C. So reciprocal of cos x. Cosec, the third letter is S. So it's the reciprocal of sin x. And cot, the third letter is T. So it is the reciprocal of tan x. देन हमने कहा डिस्कस किया था कि क्वाड्रेंट्स क्या होते हैं, राइट? क्वाड्रेंट्स में क्या पॉजिटिव होता है? तो इन फर्स्ट क्वाड्रेंट ऑल पॉजिटिव, इन सेकंड क्वाड्रेंट साइन एंड इट्स रेसिप्रोकल कोसेक बोथ पॉजिटिव, इन द थर्ड tan and cot positive, and in the fourth cos and sec positive. Then we solved the equation cot x equals 4 over 3. Then we saw the identities, 5 identities. Out of these 4 were there in the formula sheet. Then using the identities we solved 2 examples, and definitely you would have recapped as would have recalled it as well. Then we visited compound angle formulas. Compound angle formulas were given in the formula sheet. We just need to are there in the formula sheet, and we just need to learn its application, right? So application, sine A plus minus B is sine A cos B plus minus cos A sine B. So I told you that if while expanding sine, if it's a plus, it will be converted to a plus. If it's a minus, it will be converted to a minus sign. Similarly, if you are expanding cos, if it's a positive sign, it will be converted to minus, and a negative sign would be converted to plus. So cos A plus minus B is cos A cos B minus plus sine A sine B. Then moving on towards tan A plus minus B, tan A plus minus tan B upon 1 minus plus tan A tan B. And then we saw its application, how to open sin x plus 30, cos x plus 30, tan x plus 30, and then cos x minus 30 minus 3 times sin x minus 30. And we all studied these compound angle formulas. We also recalled that in AS we were required to remember few trigonometric ratios, special angles, trigonometric ratios of special angles were to be recalled. And we recall that sine 30, 45, and 60 is half, 1 over root 2 and root 3 over 2. Sine increases as we move from 0 to 90 degree. Cos decreases as we move from 90 degree towards 0. As we move from 0 to 90 degree, cos decreases. So that is why it's root 3 over 2, 1 over root 2, and 1 upon 2. The reverse of what we studied in sine. Then tan is sine over cos, so 1 over 2 divided by root 3 over 2 will give us 1 over root 3. Then as far as sine 45 and cos 45 is concerned, will give us 1, and root 3 over 2 divided by 1 over 2 will give us root 3. Right? So then we moved on. We covered all the examples, and now we are moving on towards the different area which we have not studied in the last class. That is double angle formulas. अब हम पढ़ते हैं double angle formulas, right? The first and most important thing, these double angle formulas are also given in formula sheet MF19. That is the good part. Then another thing is, these double angle formulas are derived from compound angle formulas. Although no one is going to ask us how they are derived, because they are given in the formula sheet. Now something that is given in the formula sheet, no one will be asking us the derivation of that. But still we need to know how these are obtained. So if we just try to expand and obtain sine 2a, then sine 2a can be broken into sine a plus b, sine a plus a, right? Sine 2a means sine a plus a. And if you are going to expand it using compound angle formula, then it is going to be sine a cos A plus cos A sin A. And now we can see that sin A cos A or cos A sin A are same. So one sin A cos A and one sin A cos A will give us 2 sin A cos A. So this will give us 2 sin A cos A. Now, why do we call it double angle formula? Because the angle was 2A and after expansion, the angle was A. So we saw that the ratio of the angles, is 2:1. The original angle that was given was 2A, and when we have expanded, we have got sin A and cos A. This means the ratio is 2:1. So if someone makes it 4A, let's suppose if this sin 2A becomes sin 4A, then 2 sin A will become 2 sin 2A cos 2A. Let's suppose if this becomes 6, then this A will become 3A, this A will also become 3A. So the ratio of 2:1 must be maintained throughout, right? Usually we see sin 4A at times. So sin 4A would be 2 sin 2A cos 2A. We can see that. Now, if few students are mistaken, they say that we are multiplying by 2. So why this 2 is not changing into 4? We are not multiplying both the sides by 2. Please remember, we are only multiplying the angles by 2. The ratio of the angles must be 2:1. If you are multiplying both the sides by 2, then it would be 2 sin 2A is identical to 4 sin A cos A. 2 sin 2A will be identical to 4 sin A cos A if we are multiplying both sides by 2. But if you're just multiplying the angles, over here it's 2A, over here it's A, over here it's A, so the ratio is 2:1. Please remember, that is why we call it double angle formulas. Now, how these double angle formulas are derived? They are derived using compound angle formulas, as we have already seen. Now, if we move on towards the derivation of cos 2A, let's see what happens. Cos 2A is again cos A plus A. And if you're going to expand, it is going to become cos A minus, when we are expanding cos, positive gets converted to minus, right? So cos A minus sin A sin A. Now, if we see, this will become, these are all identity signs, right? So cos square A minus sin square A. Now, this is the very first version of cos 2A, as we can see over here. Now, from this version, how do we convert into version number 2? Version 1, version 2, version 3. Now, how can we convert into version number 2? So it's a very common sense question. Using identity number 1, if we have to convert this entire into cos square A, then I will replace sin square A. Sin square A plus cos square A is identical to 1. So sin square A will be identical to 1 minus cos square A. So let's do it. Cos square A minus sin square A, and sin square is 1 minus cos square A. If you are going to expand it, it is going to become cos square A minus 1 plus cos square A, which at the end will become 2 cos square A minus 1. Okay, so cos square A minus sin square A gets converted to 2 cos square A minus 1. Similarly, if you are to change cos square A minus sin square A into sin square A completely, then what we can do is cos square A will be 1 minus sin square A, right? So 1 minus sin square A minus sin square A. So now this will be converted to 1 minus 2 sin square A. So the bottom line is that if we expand sin A plus A, we get only one version. But if we expand cos A plus A, we get 3 versions. Version number 1, version number 2, version number 3. Now, which version to use which version will be used when we see cos 2A? Now, that depends. That depends upon the question being asked upon the question being asked by the examiner. At times, the examiner tells us that we need to convert the entire thing into cos. So then we are going to use 2 cos square A minus 1 in place of cos 2A. And at times the examiner tells us to convert the entire thing into sine square a. So in that case, wherever we see cos 2a, we'll substitute 1 minus 2 sine square a. So usually we use 2 cos square a minus 1 or 1 minus 2 sine square a, because the general version cos square a minus sine square is not used, because when we are solving trigonometric equations as well, we need one trigonometric ratio only. So then only we can comfortably solve. So either we convert the entire thing into cos, or we convert the entire thing into sine. It depends upon the question. We are going to see the questions later, and we'll see how we will use the identities that basically are required in those particular questions. If we are going to see the third relationship, if we see the third part, then it's tan 2a. Tan 2a is tan a plus a. This is tan a plus tan a upon 1 minus tan a tan a. So tan a plus tan a is 2 tan a, and 1 minus tan a tan a is 1 minus tan square a. All right. So it's basically the final answer of tan a plus a is 2 tan a upon 1 minus tan square a. So we can see that these compound angle formulas are also present in the formula sheet. Let me show you. 4 identities. We already saw these. Then 3 compound angle formulas. Now 3 double angle formulas. Sin 2a is 2 sin a cos a. Cos 2a has 3 versions. 1, 2, and 3. And tan 2a is 2 tan a upon 1 minus tan square. So we have studied all this now. And these all are given in the formula sheet. This means we need to learn its application. The main compound angle formulas are also given, and the double angle formulas which have been derived using the compound angle formulas are also given. So what else do you need? Examiner has given everything. So there's no difficulty. The only thing is that you need to learn the application of it, right? So not a big deal, inshallah. You can manage that very easily. Note this down and let me know if you people are clear till here. And if you're done, then write on the chat, clear and done, so we can move forward. If anyone wants to ask something, they can raise their hands and ask.
सर ये मुझे समझ नहीं आया, ये जो साइन ए है, अगर साइन 2a है तो हमारे पास कॉस कहाँ से आ रहा है?
साइन 2a है तो कॉस कहाँ से आया?
और कॉस
ये
भी फिर
कॉस की
साइन
बात कर
कैसे
रहे
आ
हो?
रहा है?
ये
हाँ।
कह रहे हो?
हाँ मतलब कॉस से कैसे आ रहा है हमारे पास? साइन ए है,
मतलब
साइन 2a को अगर हम
ये
लिखना है तो।
देखो ना, ये रही ना, दिस इज द कंपाउंड एंगल फॉर्मूला. साइन ए प्लस माइनस बी इज साइन ए कॉस बी प्लस माइनस कॉस ए साइन बी. तो दिस इज द एक्सपेंशन कंपाउंड एंगल फॉर्मूला में.
अच्छा
तो
अच्छा अच्छा, सही
साइन,
है सही है सही है,
so
तो
if
समझ
if
आ
I am
गया।
going to take a over here, then over here it's going to be a, and over here also it's going to be a. Then sin a cos a and cos a sin a are same only. But 2 into 3 या 3 into 2 सेम होते हैं ना. तो sin a
हम्म।
into cos a and cos a into sin a भी सेम होते हैं. तो sin a cos a sin a are same. So if we are going to add both of them, then it's going to become 2 sin a cos a.
तो
All
सर
right.
ये वाले मतलब ये वाले क्वेश्चन करते हुए आप ये फॉर्मूला शीट खोल के रखो।
बस दिस इज व्हाट यू नीड टू डू. आपने फॉर्मूला शीट खोलनी है और सामने रखनी है. मैं हमेशा यही कहता हूँ, whenever you are solving a trigonometric question, what you have to do is you have to keep the MF19 trigonometric section in front of you. So then only you will be able to identify कि कौन सी आइडेंटिटी यहाँ पर इस्तेमाल करनी है, which identity to use at that time. You will see. अगर सामने खुली हुई होगी फॉर्मूला शीट तो ही आप बता सकते हो, तो ही आपको सही सॉल्व हो सकता है, वरना कहीं ना कहीं गड़बड़ कर दोगे. तो वो सेक्शन आपने सामने रखना, बिल्कुल सही पिक किया आपने. जबरदस्त. All right. Now copy it and
जी सर
then
ठीक है।
acknowledge. All right, have you people noted down? Should I move forward or are you writing? Still writing? Done हो गया ना? चलें, great. Alia, are you done? Okay, great. चलें, moving forward. Now, if we have to expand, example says express cos 3x in terms of cos x. So if we want to expand cos 3x and we have to obtain it in terms of cos x, what we can do? Cos 3x is, always remember that if there is an odd number involved, because cos 3x, 3 is an odd number, right? So whenever we are to expand cos 3x or cos 5x or cos 7x, then we split it and we use compound angle formula. However, it's 4, if it's cos 4x, if it's an even number, then we can directly use the double angle formula. If it's cos 6x or 4x, then also we can use the compound angle formula, but it's more convenient to use the double angle formula. So I'll be writing down and then I'll be explaining what I'm trying to say. It will take some time. So inshallah, let's see. So cos 3x is cos 2x plus x. And now if we are going to expand it, it is going to be cos 2x, cos 2x, cos x minus sin 2x, sin x. So this is the very first step. Cos 2x plus x is cos 2x cos x minus sin 2x sin x. Now in place of cos 2x, I'm going to substitute. What will I substitute? I want to express cos 3x in terms of cos x. And for cos 2x, I have three versions. Version number 1, version number 2, and version number 3. As I have to convert it into cos x, so I am going to use the cos version. So in place of cos 2x, I'm going to use, also we need to see that if it's x over here, then we don't have to take a, we have to take x only, right? So cos 2x is 2 cos square x minus 1. At times at times I've seen students writing a, x, theta in the same question. So you have to see which angle is being involved. Is it a, is it b, is it x, is it theta? Whatever it is, you have to follow the instructions and you have to write only that angle. You cannot write, because एक मुहावरा है ना उर्दू का, नकल के लिए भी अकल की जरूरत होती है. So they just try to copy that from the formula sheet, and whatever is there in the formula sheet, they use that only. So in formula sheet, it's a. In formula sheet, we see that there's a in the double angle formula. So they try to use a only. But in the question, if it's x, then you have to use x, because over here, over there, there's no involvement of a. So you have to use as per the requirement of the question, which variable the examiner is trying to use. You have to use that variable only as per the requirement. Now, as you have to convert into cos x, now as from three versions of cos 2x, we are using 2 cos square x minus 1. This is 2 cos square x minus 1, and then cos x as it is. Sin 2x has just one version. Sin 2x is 2 sin x cos x. Two sin x cos x multiplied by sin x. Right? And if you are going to multiply, this is going to be 2 cos cube x minus cos x, then minus 2 sin square x cos x. 2 cos cube x minus cos x minus 2 sin square x cos x. But I have to convert into cos x. So what I am going to do? क्या करेंगे भाई? कौन बता रहा है? मुझे cos x में convert करना है. क्या करूं? What should be done? Yes. You can participate on mic as well by raising your hand.
सर साइन स्क्वायर को 1 माइनस कॉस स्क्वायर.
Very good. Sin square को 1 minus cos square. Perfect. Because we have to convert to cos x. So in place of sin square, we are going to use 1 minus cos square. Perfect. 2 cos cube x minus cos x and minus 2. Then sin square x is 1 minus cos square x into cos x. This is 2 cos cube x minus cos x minus 2 into cos x is minus 2 cos x, and then minus 2 cos x will be multiplied by 1. So minus 2 cos x minus 2 cos x, then minus 2 cos x will be multiplied by minus cos square x. So plus 2 cos cube x. 2 cos cube x minus cos x minus 2 sin square x cos x, then sin square x is 1 minus cos square x. So 2 minus 2 cos x plus 2 cos cube x. Then 2 cos cube plus 2 cos cube is 4 cos cube. So it is 4 cos cube x, 4 cos cube x minus 3 cos x. So cos 3x is identical to 4 cos cube x minus 3 cos x. So this is going to be the simplified final answer. So when there was cos 3x, this 3 was an odd number. So we need to expand it using compound angle formula by breaking 3x into 2x plus x, and then using the compound angle formula of cos, which is already present in the formula sheet. And then when we have expanded, we have seen cos 2x and sin 2x popping up. So in place of those, I've used the double angle formulas. And then after that, because I had to convert into cos, I saw that there was sin square x. Using the very first identity that we studied in AS as well, we replaced sin square x with 1 minus cos square x. We multiplied, we simplified, and we got the answer. So write this and write in the chat, done and clear, so we can move forward. Which step, Alia? Second step. You mean this step?
Yes, sir.
Alia, cos 2x is written in the formula sheet. You can see. I've already told above as well. Cos 2x क्या होता है? Cos 2x. This cos a plus a is cos 2a, right? So it's written cos 2a is 2 cos square a minus 1. So in place of a, there is x. So over here is it's x. So cos 2x is basically 2 cos square x minus 1. So in place of cos 2x, I have used 2 cos square x minus 1. In place of sin 2x, I've used 2 sin x cos x. And both of these are given in the formula sheets. I've just used x in place of a. So now check it out. I've expanded using compound angle formula. In place of cos 2x, I've used 2 cos square x minus 1. In place of sin 2x, I've used 2 sin x cos x. Then I multiplied 2 cos square x minus 1 with cos x and 2 sin x cos x with sin x. I expanded and I simplified, and then I got this answer. Is it clear now, or anything more to be explained? Yes, Ari, is it clear?
Sir, why do you multiply by cos x after the bracket?
Because these both are multiplying. We have to multiply. मल्टीप्लाई का साइन तो होगा ना, जब दो चीजें मल्टीप्लाई हो रही हैं तो मल्टीप्लाई होंगे ना. क्या करें, मल्टीप्लाई नहीं करेंगे तो क्या करेंगे और बताओ. 2 cos square x minus 1 को cos x से मल्टीप्लाई तो करेंगे, दोनों माइनस से पहले ही है ना, और ये भी आपस में मल्टीप्लाई होंगे. cos 2x cos x का मतलब ही क्या है? मल्टीप्लाई ए बी क्या होता है? व्हाट इज द मीनिंग ऑफ ए बी? लेट्स सपोज ए बी लिखा हुआ है, ए बी का मतलब ही ए मल्टीप्लाई बाय बी है, तो ये तो these both are written together, so this means they are being multiplied.
Okay, sir.
Okay, clear? Have you noted it down as well?
Yes, sir.
All right, moving on towards cos 4x. Cos 4x has to be expressed in terms of cos x, right? Now, if you are going to express cos 4x in terms of cos x, then firstly we need to see that is 4 an odd number or an even number. So because it is an even number, we can directly expand it using compound angle formula. Sorry, using a double angle formula. Like let's suppose if someone is splitting by using the compound angle formula, that the working will be very long. Just try to understand what I'm trying to communicate over here. We know that from the formula sheet, cos 2x is identical to 2 cos square x minus 1. Right? In the formula sheet, it's cos 2x is in the formula sheet, it is in terms of a, but if we are taking in terms of x, then its cos 2x is identical to 2 cos square x minus 1. Altogether, there are 3 versions, but we are taking the cos version. 3 versions हैं, लेकिन हम cos वाला version ले रहे हैं. Why? Because the examiner has told us that we have to express cos 4x in terms of cos x. Okay, so this is the double angle formula that we can directly use. How? If we have to expand cos 4x, then in place of 2x, I'm going to take 4. So in place of x, I'll take 2x. The ratio of 2:1 must be maintained. So now if I'm writing cos 4x over here, cos 4x is identical to 2 cos square 2x minus 1. Now this is 2 times cos square 2x. So cos square, what is the meaning of cos square 2x? We know that cos square x means cos x whole square. Cos square x means cos x whole square. So if it is 2 cos square 2x, then I can write 2 cos 2x whole square minus 1. Just like cos square x is cos x whole square, similarly, cos square 2x is cos 2x whole square. Right? So cos 4x is 2 cos square 2x minus 1, and cos square 2x can be rewritten as cos 2x whole square. Then in place of cos 2x, I'm again going to substitute this. First, I use the double angle formula to find cos 4x in terms of cos square 2x. And then when I've seen cos 2x popping up again, I'll use this double angle formula once again in the original form. Previously, I changed the original form of it. In place of 2x, I took 4x. In place of x, I took 2x. But now I am changing the original form. I'm not changing the original form. I'm just taking the original form. So this is 2 cos square x minus 1. So I'm going to substitute it. 2 times 2 cos square x minus 1 whole square minus 1. Cos 2x is 2 cos square x minus 1. I'm going to square it. And if I'm going to square it, this is 2 cos square x minus 1 whole square is 4 cos 4x. How will we expand it? A minus b whole square. कैसे expand करेंगे? A minus b whole square से इसको expand करेंगे. So 2 cos square x minus 1 whole square is 4 cos 4x minus 2 2 is a 4. 4 cos square x. Minus 1 का whole square is plus 1. And में है minus 1. So cos 4x is 2 cos square 2x minus 1. Cos square 2x is cos 2x. Cos square 2x is cos 2x whole squared. Then cos 2x is 2 cos square x minus 1. And I'm going to square it. So 2 times 2 cos square x minus 1 whole squared minus 1. So if I'm going to expand 2 cos square x minus 1 whole squared, I'm going to get 4 cos 4x minus 2 to the 4, 4 cos square x minus 1 whole square is plus 1 as per a minus b whole square. Then if I'm going to multiply, I'm going to get 8 cos 4x minus 8 cos 4x minus 8 cos square x plus 2 minus 1. Then if I'm going to simplify, I'm going to get 8 cos 4x minus 8 cos square x plus 1. So this is going to be my final answer. Cos 4x is identical to 8 cos 4x minus 8 cos square x plus 1. So I had to express cos 4x in terms of cos x, and I've already done that, right? Cos 4x is in terms of cos x only. Why? Because cos power 4x is basically cos x whole power 4. Cos square x is basically cos x whole power 2. Are you getting it or not? Yes, समझ में आ रही है बात? कोई चीज कंफ्यूज करी तो बताओ.
सर ये सेकंड लाइन पे जब 2 cos स्क्वायर 2x है तो वो एकदम से 2 cos 2x टू द होल स्क्वायर क्यों हो गया?
यही तो मैं समझा रहा था कि cos स्क्वायर x क्या होता है. जब मैं cos स्क्वायर x करता हूँ तो ये क्या होता है? cos x का होल
cos x
स्क्वायर.
करके उसको स्क्वायर हो जाता है, हाँ।
तो इसी तरह अगर मैं आपको कह दूं कि cos स्क्वायर 2x है, वो क्या होगा? cos ऑफ 2x का होल स्क्वायर हो. जब cos 2x पे होल स्क्वायर लगता है तो ये थोड़ी है कि 2x पे स्क्वायर लगता है. स्क्वायर तो cos पे ही लगता है. तो cos 2x होल
हाँ
स्क्वायर इज बेसिकली cos स्क्वायर 2x. जब ये चीज इसमें कन्वर्ट हो सकती है तो ये वाली चीज में भी कन्वर्ट हो सकती है.
हाँ, ठीक है ठीक है।
तो cos स्क्वायर 2x को मैंने cos 2x होल स्क्वायर बना दिया. जैसे ही बनाया फौरन नजर आ रहे cos 2x, ये तो फॉर्मूला शीट में गिवन है. मैंने कहा चल भाई डाल दे, फिर किसका इंतजार कर रहा है. तो cos 2x की जगह 2 cos स्क्वायर x माइनस 1 डाल दिया. जैसे ही डाला तो स्क्वायर इंतजार कर रहा था एक्सपेंशन का. इसको हमने a माइनस बी होल स्क्वायर से एक्सपेंड करके a स्क्वायर माइनस 2ab प्लस बी स्क्वायर से खोल लिया. a स्क्वायर इज 4 cos 4x, 2ab 2 into 2 cos square x into 1. So 4 minus 4 cos square x or plus 1, 1 का स्क्वायर प्लस बी स्क्वायर 1 का स्क्वायर प्लस 1. एंड में माइनस 1 एंड में आ गया. Then we multiplied 2 with all these three terms. We subtracted minus 1 and we got the simplified version. Right? So what we see was, अच्छा कोई अगर मैं वही कह रहा था, कोई अगर कहता नहीं भाई मैं कंपाउंड एंगल फॉर्मूला से खोलूंगा. लेट्स सपोज अगर कोई मेथड 2 को फॉलो करने की कोशिश करता है, ये तो मेन मेथड है ना, मेथड नंबर 1, ये सबसे प्रेफर्ड मेथड था, यही करना था आपने. तो कोई कहता नहीं भाई मैं तो डबल एंगल फॉर्मूला से नहीं खोलूंगा, जबकि मैंने सजेशन क्या दी. व्हाट वाज द सजेशन? if 4 is an even number, then we need to use double angle formula directly, because 2 is to 1, as per the 2 is to 1 ratio, we can easily manage it. But if it was 3x, we couldn't use double angle formula, वरना डेसिमल में आ जाता, 1.5x हो जाता. 3x and 1.5x. So that is why यहाँ पर हम क्या करेंगे कि cos 4x जो है, cos 4x है ना, cos 4x को हमने क्या कह रहा था, हाँ, cos 4x को we can split like cos 2x plus x. And if you are going to use the compound angle formula, it is going to be cos 2x minus sin 2x sin 2x, which is basically cos square 2x minus sin square 2x. So if we have used the compound angle formula, double angle formula is already हम processing कर चुके थे ना. Like when we were deriving the double angle formula from compound angle formula, then we already found 3 versions. But now if I'm going to use the compound angle formula, I have first found the first version. Then in place of sin square 2x, I'll have to substitute 1 minus cos square 2x. Then I'll see 2 cos square 2x minus 1, and then the entire process will be repeated. तो समझ लें ये सारे शुरू के एडिशनल स्टेप्स होने थे, एंड आफ्टर दैट द एंटायर वर्किंग दैट वी हैव ऑलरेडी डन ओवर हियर वाज टू बी रिपीटेड. So this means this is very, very long, very long. This means it's not preferred, right? This means if it's if it's an even number, like 4 was an even number, the angle involves an even number. Angle was 4x, which involves 4, which is an even number. So we need to use the double angle formula directly rather than using the compound angle formula. However, if it's 3x, usually we see 3x and 4x only. So if it's 3x, we use the compound angle formula. If it's 4x, we use the double angle formula directly. Right? Note it down and let me know if it's clear or not. Okay, great. Have you people noted down? Moving forward then, right? Done, right? It's clear you have written, this means you have done it as well, right? Okay. So now moving on towards harmonic form. You people have copied it, na? Done लिख दिया करें, मुझे confirmation नहीं होती ना, फिर तसल्ली नहीं मिलती. So please write if you're done. चलें जबरदस्त. चलें moving forward harmonic form को देखते हैं. Harmonic form, harmonic identities. Basically, A sine theta, there are two types of expressions that we are seeing. If A and B are positive, harmonic form, if A and B are positive, अगर A और B जो है वो positive हैं, then number one, A sine theta plus minus B cos theta will be identical to R sine theta plus minus alpha, and A cos theta plus minus B sine theta will be identical to R cos theta minus plus alpha. Now, just you need to focus on this. I'll explain it. Now, you have been given an expression and you are told to convert. The examiner will guide you. Examiner will give the values of A and B. Let's suppose if A is 4 and B is 3. So examiner will tell you 4 sine theta plus minus 3 cos theta is to be converted to R sine theta plus minus alpha, where the values of R and alpha are to be found. The values of A and B will be given by the examiner, and you will be given an expression and you will be told to convert it. So you will be given in harmonic form and you will need to convert it into sine or cos form. So how can we do that? So always remember one thing. Whenever the examiner is asking you to convert into sine, the first term has to be in terms of sine theta. In terms of sine. If you are to convert into sine, then the first term has to be in terms of sine and the second term has to be in terms of cos. And if the examiner has asked you to convert into cos, then you need to note that the first term will be in cos and the second term will be in sine. Now, this is what you see by default only. This will be very specifically given and you'll be seeing and you will just be matching. I always say कि भाई एहतियातन check कर लो. Just to be on the safe side, check this. This is very, very important. कि अगर आपको conversion sine में करनी है, if you're told to convert into sine, then the first term has to be in sine. If you're told to convert into cos, then the first term has to be in terms of cos. If this is not the case, then you need to reverse the order. Let's suppose if you are told to convert into R cos theta minus alpha, but you are seeing A sine theta, you are seeing 3 sine theta plus 4 cos theta. You are seeing this and you have to convert into cos. Then you must realize that you need to shuffle this, right? You need to convert it into 4 cos theta plus 3 sine theta. Why are we doing that? Because we need to convert into cos, the first term has to be in terms of cos. कन्वर्जन कॉस में करनी है तो पहला टर्म कॉस में होना चाहिए, कन्वर्जन साइन में करनी है तो पहला टर्म साइन में होना चाहिए. वेरी 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 इंपॉर्टेंट, बहुत इंपॉर्टेंट है ये बात. सही है, दिस इज नॉट अ जोक, दिस इज वेरी इंपॉर्टेंट. तो इफ a and b are positive, if a and b are positive, then this means a and b both have to be positive. Even if there is a negative sign, then we need to take b as positive only. Let's suppose if it's 3 sine theta minus 4 cos theta, then this minus will result in conversion into minus, but this 4 will be taken as positive and 3 will be taken as positive, right? So a and b are positive constants always. Okay, one another thing that we need to note, if the examiner has asked us to convert into sine, then if there was a positive sign in the harmonic form, after being converted, it is going to be positive only. क्योंकि साइन के केस में साइंस क्या रहती हैं, सेम रहती हैं. And in case of cos, if we are converting into cos, then if there was a positive sign, then it gets converted to a negative sign. So the signs will be opposite. You know how we actually find r and alpha? By expanding this. How can we expand this? You know, by using compound angle formula. Let's suppose if it's r sine theta plus alpha, then what we can do is r sine theta, r bracket sine theta cos alpha plus cos theta sine alpha. Then if you are going to compare the coefficients, then we are going to get the value of alpha and r. But we are not required to follow this long process. At times, teachers teach this long process, but even in books, the direct shortcut is written and you need to follow that direct shortcut because it is not going to give you that much marks. Whenever we are told to convert, it is normally a 3-mark requirement. 1 mark you get for the value of r, and 1 mark you get for the method for using trigonometric formula. This means using tan alpha equals to b over a, and the 3rd mark for the value of alpha. So a sine theta plus minus b cos theta is identical to r sine theta plus minus alpha. This is not something that you need to remember. याद तो हो ही जाएगा, but examiner will always be, mostly he will be telling you. हमने जितने भी सवाल पास ओवर में देखे हैं उसने बताता है वो, लेकिन हमें फिर भी याद होना चाहिए कि अगर a sin theta plus minus b cos theta है, तो we need to convert it into r sin theta plus minus alpha. Why? Because it starts with sine, so we need to convert into sine. If it starts with cos, then we need to convert into cos. So this thing needs to be noted. Why is this important? This is important because if you are converting into sine, the first term has to be sine because the coefficient of sine would in that case be a. If the first term is cos, then the coefficient of cos will be a. A at times is the coefficient of sine theta, at times it is the coefficient of cos theta. So which value we need to take? Like, will a be the coefficient of sine theta or cos theta? It will depend upon the conversion. If we are converting into sine, then the coefficient of sine will be a and the coefficient of cos will be b. And if you are converting into cos, then the coefficient of cos will be a and the coefficient of sine will be b. So usually this is guided and told by the examiner. We just need to find the value of r and alpha. Now, even if a and b are swapped, there is no difference in the value of r. The value of r will still remain the same because if r equals root of a square plus b square, then even if a and b changes their places, this is not going to create any difference to the value of r. But as far as alpha is concerned, because tan alpha is b over a, so if the values of a and b changes, the angle alpha will change. So this means it is very, very important to note that if you are converting into sine, the first term has to be in sine and the coefficient of sine will be a. And if you are converting into cos, then the first term has to be in cos and the coefficient of cos will be a. Once we have decided the values of a and b, then the formula for r is root of a square plus b square. And the formula of alpha is tan alpha equals b over a. And if we are going to find alpha out of it, we are going to send tan to that side. So alpha is going to be tan inverse b over a. At times, the examiner asks us to find the exact value of tan alpha. So if we are told to find the exact value of tan alpha, then it is b over a and we'll stop. I will not proceed any further. But if the examiner has asked us to find the value of alpha, then the alpha is tan inverse b over a. The point to note is that alpha will always be an acute angle. This alpha will always be an acute angle. It will always lie between 0 and 90. If I talk about radians, it is always going to lie between 0 and pi by 2. So if the expressions are given in harmonic form, then we can convert into sine and cos depending upon what the examiner has told us. If the examiner is silent, then we need to see that if sine theta is it's starting from sine theta, we can convert into sine. And if it's starting from cos, we'll convert into cos. But when we are converting into sine, we need to see that the signs will be opposite. If it's a positive sign over here, then it's a positive over there as well. If it's the negative, then it's a negative over here. Plus minus gets converted to plus minus. But if it's starting from cos and being converted into cos, then plus minus gets converted into minus plus. Plus minus plus में convert हो जाएगा. कुछ समझ में आ रहा है या मैं अपने आप से बातें कर रहा हूँ भाई? थोड़ा सा बता दें, थोड़ा सा जो है वो feedback चाहिए, so that I can move forward. Is it clear to everyone, or is there something that you are not able to understand? I'm going to cover the
थोड़ा बहुत
examples, so you are going to
कंफ्यूजिंग है।
get better. Confusing है, आगे समझ आ जाएगा इंशाल्लाह. एग्जाम्पल पे आ जाऊं फिर समझ आ जाएगा.
ठीक है।
यहाँ कुछ लिखना है नहीं, बस को अप्लाई करना है. फॉर्मूला में अभी बताता हूँ इंशाल्लाह. एक दो एग्जाम्पल्स करवाने दो, अभी समझा देता हूँ. सही है, एग्जाम्पल करते हैं फिर ज्यादा समझ आ जाएगा, इसलिए अभी घबराते नहीं है. बस ये दो एग्जाम्पल जी तो करने, फिर ट्रिग्नोमेट्री खत्म है इंशाल्लाह. ऑलराइट, सो लेट्स फॉलो फर्स्ट एग्जाम्पल. Explanation will end inshallah, and then you will be in a position to attempt the questions as well. So if we talk about part number 1, then express 3 cos theta plus 4 sin theta in the form r cos theta minus alpha, where alpha lies between 0 and pi by 2. Now just check out. If the examiner has guided us, the examiner has specifically given an instruction. Examiner ने वाज़े तौर पे instruction दी है. क्या instruction दी है? The examiner has told us that 3 cos theta plus 4 sin theta has to be converted to r cos theta minus alpha. The point to note is that as we are converting into cos, the first term has to be cos theta. And the cos theta coefficient will be the value of a. And we are also noting that as we are converting into cos, so if it's a negative sign over here, we see that there is a positive sign over here. So both things should match. Conversion into cos, the first term has to be cos, and the plus sign gets converted into a minus sign. Now, how to go about it? First, let's lock the values of a and b. So what is going to be the value of a? The value of a, the coefficient of cos theta will be the value of a, so a is 3. The coefficient of sin theta will be the value of b, so b is going to be 4. So if you are going to find the value of r, is r equals root of a square plus b square. So root of 3 square plus 4 square. Root of 9 plus 16 is root of 25, which will give you 5. The value of r will be 5. If I talk about alpha, then we know that the formula of tan alpha is b over a. Tan alpha is 4 over 3. But we don't have to find tan alpha, we need to find alpha. So if tan alpha is 4 over 3, then alpha is going to be tan inverse 4 over 3. So tan inverse 4 over 3 is going to be 53.130. We know that if you are working in degrees, then workings should be in 3 decimal places. And the final answer has to be in 1 decimal place. Just give me a minute. Yes. So we were saying that if we have to convert into cos, then the first term has to be in cos. So the coefficient of cos will be a, and the coefficient of sin in that case will be the value of b. So the value of a is 3 and the value of b is 4. If you have to find r, the formula is root of a square plus b square. The answer will be 5. If you have to find the value of alpha, then it's tan alpha equals 4 over 3. And for finding alpha, we are going to send tan to that side. So alpha equals tan inverse 4 over 3. And this will give us 53.130. So which accuracy do we have to give? So we know that if we are dealing with angle in degrees, we are dealing with angle in degree. Okay, so, sorry, my bad. I'm mistaken. बाहर शोर इतना आ रहा था ना, my what I'll say, my little niece was nephew niece was crying a lot. इतना शोर हो रहा था कि I was like not able to concentrate. थोड़ा सा मुझसे गलती हो गई. यहाँ पर जो है वो रेडियन में काम करना है, because the domain is in radians, right? So यहाँ पर जो है वर्किंग 3 डेसिमल प्लेस और 1 डेसिमल प्लेस, ये जो रूल है ना, ये डिग्रीज के लिए होता है. एंगल इन डिग्रीज के लिए होता है ये रूल. बट ओवर हियर वी आर डीलिंग इन रेडियंस, राइट? सो रेडियंस की रिक्वायरमेंट कुछ डिफरेंट होती है. रेडियंस की रिक्वायरमेंट इज इन सिग्निफिकेंट फिगर्स. सो एंगल इन डिग्रीज, इट्स, if we are talking about non angles or if we are talking about angle in radians, in both the cases the working has to be in 5 significant figures, and the final answer in those cases will be correct to 3 significant figures, right? So over here we have to work in radians. So first change your calculator to radian mode and then calculate. So tan inverse 4 over 3 is basically 0.927 0.927295. So it's 730, 92730. So we are working in 5 significant figures. So 0.92730 and 0 of course has no significance, so we can only write 0.9273. Okay, so we will not write 0 at all the places. Just to let you all know that in 5SF it's 0.92730, and we have found the value of alpha. Okay, but we had to convert into this form, right? So let's put back the values of r and alpha. So the final answer is going to be 5 cos theta minus alpha, and alpha is 0.92730. 9273. This is our final answer. Tan alpha is 4 over 3, alpha is 0.92730. So the final answer will be 5 cos theta minus 0.9273. This is the answer of part number 1. Okay, so I mistakenly wrote degree, but now I have written radians. So if I move on to part number 2, the part number 2 that you are seeing over here is very rare. If you are going to solve 10 years past papers, you'll hardly see 2 or 3 questions of this type. But making this a part of examples is actually intentionally why I've intentionally made this the part of our notes, because if something is written in the notes, then naturally you'll recap and review it again and again, right? You will review and recap it again and again. So this means that if you have to find the minimum and maximum value of 10 upon 6 minus 3 cos theta minus 4 sin theta, then whenever the question involves finding the minimum and maximum value, you will always be using the harmonic form, converted form that you have found in part number 1. So how to use that? Let's check it out, so that whenever you face such a question, and even if you are unable to practice much questions in past papers, then at least it is a part of your example, so that whenever it pops up in your exam, you are able to deal with it comfortably, inshallah. So part number 2 says find the minimum and maximum value of 10 over 10 divided by 6 minus 3 cos theta minus 4 sin theta. So if I'm going to take minus as common, then I'm going to get 3 cos theta plus 4 sin theta, right? 3 cos theta plus 4 sin theta. Then we know that 3 cos theta plus 4 sin theta has already been converted in part number 1. So we are going to replace it. So this is going to be 10 upon 6 minus 5 cos theta minus 0.9273. Now, whenever we have to find the minimum maximum value and cos and sine are involved, we always need to know that whether it's cos or whether it's sine, they always lie between -1 and 1. Whether it's sine or whether it's cos, they always lie between -1 and 1. Sine theta and cos theta both lies between -1 and 1. So always remember that whenever we have to find the minimum maximum value, one time the cos of angle, no matter what the angle is, whether angle is simply theta or whether the angle is theta minus 0.9273. If cos is being applied on an angle, then no matter what the angle value is, no matter what the value of the angle is, if cos is applied on a certain angle or if sine is applied on a certain angle, the answer of sine and cos can never be lesser than -1. The answer of sine angle or cos angle can never be less than -1 and it can never exceed 1. हमेशा आंसर -1 से 1 के दरमियान होगा. -1 से कभी छोटा भी नहीं हो सकता और 1 से कभी बड़ा भी नहीं हो सकता. Right? So what we can do, one time we are going to substitute -1, then we are going to substitute 1 as well. Now the common sense says, usually students think that when we have to find the minimum value, we'll substitute the minimum value. When we are going to find the maximum value, when we have to find the maximum value, we can substitute 1. But this is not always the case. Although this might be true over here, but this is not always the case. Also, I need to tell one thing, that at times there is square as well as involved. Let's suppose there was a square over here. Then -1 and 1 would give the same answer. So in such cases, the special value of 0 should also be used. So I always tell students that whenever you have to find the minimum maximum value, you have to substitute SV means the special values. The 3 special values that you were taught in AS as well: 0, -1 and 1. Cos 90 is 0, cos 0 is 1, cos 180 is -1, cos 270 is 0, and cos 360 is 1. Similarly, sin 0 is 0, sin 90 is 1, sin 180 is 0, sin 270 is -1, sin 360 is 0. So 0, 1 and -1 are the special values. So whenever you have to find the minimum maximum value, always substitute 0, -1 and 1 in place of cos angle or sine angle. Always substitute 0, -1 and 1 in place of cos angle or sine angle, and then see which value gives you the minimum value and which gives you the maximum value. You have to choose the value right there and then after calculation. So if I'm going to try over here, just a simple try, then I'll see what happens. Okay. Now just allow me to try it out. If I'm going to substitute, this is 10 upon 6 minus 5 times 0. One time we have substituted this, and 10 upon 6 minus 5 times -1, then 10 upon 6 minus 5 times 1. So 10 upon 6 minus 0 is 2 5s are 10, 2 3s are 6, it's 5/3. If you are substituting -1, then 10 upon 6 minus 5 times -1, 6 plus 5, 11, it's 10/11. And if I'm going to substitute 10 over 6 minus 5, then 6 minus 5 is 1. So it is 10 upon 1 is 10. So now we can see from here that 10 upon 11 is the minimum value and 10 is the maximum value. Now usually the students note that, sir, when we substituted -1, we got minimum value. When we substituted 1, we got the maximum value. Is this always the case? No. This is not always the case. This is coincidentally the case over here, but not at times when we substitute the positive value, that is 1, we get minimum value. And when we substitute the minimum value, that is -1, we get the maximum value. And at times, because there is a square involved, or there is some yes, if there is a square involved, or in certain cases, at times we see that 1 and -1 both are not giving one of them is giving the minimum value, but other might not give the maximum value, something like that. But I always tell my students that you have to substitute 0, 1 and -1 for safe side. Safe side के लिए 0 डाल के देखें, 1 डाल के देखें, -1 डाल के देखें, फिर डिसाइड करें. क्योंकि खासकर स्क्वायर में तो 0, 1 और -1 दोनों सेम ही आंसर देंगे, तो 0 ही डालना पड़ेगा ना. तो कहीं और भी कोई ऐसा केस आ जाए, अभी तो मेरे जहन में कोई और केस नहीं है स्क्वायर के अलावा, बट इफ देयर इज समथिंग लाइक दैट, सो सेफ साइड यही है कि cos एंगल एंड sin एंगल की जगह you have to substitute 0, 1 and -1. So with 0 we got 5/3, with -1, we got 10/11, and with 1, we got 10. So 10 is the maximum value and 10/11 is the minimum value. So out of three values, the minimum, the least is 10/11 and the greatest is 10. So this is how we need to approach such types of question. We converted in part 1 and we used the converted form in part number 2, and then substituting the special values of 0, -1 and 1, and we found the minimum and maximum values. So this is how it is. You'll see very rarely the questions in past papers, but if this is something which is part of your examples, if it's part of your notes, then it's very easy for you to recap in future. So this is the second last example that we have covered. I hope you people are clear with it. Please acknowledge if it's clear or not. Please note it down as well and write done and clear. All right, then if we move on towards the last example, then solve the equation 3 cos theta plus 2 sin theta equals 1. Normally, we see that whenever the harmonic form is involved, the examiner does not ask us to solve the equation directly. Past paper, if you are going to check out the questions, then in the first part, we are told to convert into the r sin theta or r cos theta plus alpha plus minus alpha form. And then in the second part, we are told to solve the equation. But over here, I've covered the extreme case. Usually, this is not the examiner's practice. You might not see even a single question on this. But at times in books as well, and even at times in schools and colleges when students are being assessed, the teachers usually give such questions and the students are confused. So just to give that idea that even if the examiner has not asked us to convert into r sin theta plus minus alpha or r cos theta plus minus alpha, then we need to see that when cos and sine both are involved, over here cos theta and sine theta both are involved. So when cos theta and sine theta both are involved, when sine theta and cos theta both are involved, then they are being added or subtracted, then we need to realize that this is harmonic form and we need to convert into r cos theta plus minus alpha. In this case, r cos theta minus alpha. How do we know that we have to convert into cos? So someone can bring 2 sine theta as well first. So this is not a big deal. If someone writes this as 2 sine theta plus 3 cos theta, then they can convert into r sine theta plus alpha. If the first term is sine, they convert into sine, and in such case, positive gets converted to positive. So there's an option that you use r sine theta plus alpha. But if I do not shuffle and I follow the sequence, then as it starts with cos theta, then this means I have to convert it into cos theta only. So if I'm going to do that, then 3 cos theta plus 2 sin theta gets converted to r cos theta minus alpha. So if someone shuffles and takes sin theta, 2 sin theta on the left and 3 cos theta on the right, then they will be converting into r sin theta plus alpha. So both are perfectly valid. You can use any one of them. There's no issues at all because it is not specified. If it is specified, then you have to follow that. If nothing is specified, then you can use whichever form you like. Also, as I've already told that in past papers, there's a trend that in part 1, the examiner asks us to convert and in part 2 asks us to solve the equation. But such type of questions do not usually occur in the past papers. But we need to see that whenever sine and cos both are together and they're being added or subtracted, we first need to convert them and then solve. Right? So over here, we need to convert. Let's convert. Now, because we are converting into cos, because over here it's a cos, the value of A is 3 and the value of B is 2. And if you're going to find the value of R, then it's A square plus B square. So 3 square is 9 and 9 plus 4 is 13. 9 plus 4 is 13. So R is root 13. And if you need to find alpha, then it's tan alpha is equals to B over A. So B is 2 and A is 3. Over here, we have to work in degrees. So we'll find alpha in terms of in degrees only. And in degrees, the working are correct to 3 decimal places. So if you are going to find alpha, it is going to be tan inverse. It is going to be tan inverse 2 over 3. So tan inverse 2 over 3 will give us, now the calculator should be in degree mode. So it is 33.690, correct to 3 decimal places. Writing 0 is not must because 0 has no value. So we can just write 33.69 as well. Once we have found alpha and are both, this means we have successfully converted. So this is now R is root 13 cos theta minus alpha. So theta minus alpha, which is 33.69 degrees. And this is equals to 1. So root 13 cos theta minus 33.69, root 13 cos theta minus 33.69 is equals to 1. And if you are going to make cos the subject, then it's cos theta minus 33.69 is equals to 1 over root 13. Now, you know what? After this, your AS concepts have to be very strong, because in AS, we used to learn that if the original domain is given, and over here, it's not theta, over here, it's theta minus 33.69. So we need to find the revised domain. Now, let's recall the steps of AS. Cos of an angle is positive. In which two quadrants? The first step is to identify the quadrants in which the angle lies. Right? The first step, identify the quadrant is first and fourth. And then the second step is to find the basic angle. In place of basic angle, I'm not writing alpha. Why? Because I already involved alpha over here. So I don't want to mix it. So I'm writing basic angle over here. Basic angle is cos inverse 1 over root 13. If I find this out, then this is 73.898. 73.898 degrees. Then if I have to find the values of basic angle is cos inverse 1 over root 13, which is 73.898 degrees. Then after that, I have to change the domain as well. Always remember, if we are given the domain in terms of theta, and the equation involves something else, then we need to change the domain. So we have to find the domain of theta minus 33.69. So we will subtract 33.69 throughout. So it's minus 33.69, and theta minus 33.69 lies between minus 33.69 and 360 minus 33.69. Oof, lot of space. थोड़ा छोटा करके लिख लेते हैं. 33.69. This is minus 33.69, and theta minus 33.69. Then we have to subtract 360 minus 33.69, which is 326.31 degrees. Now this is the revised domain. Then if we are going to the first step, identify the quadrants, then find the basic angle, the second step, then revise the domain if required, change the domain if required. Then we give the answers of this changed domain, because over here the angle is 33.69. So we are going to give the answers of 30 theta minus 33.69. Once we get the answers of theta minus 33.69, from that we are going to get the values of theta. So theta minus 33.69 has to lie between minus 33.69 and 326.31. So if we are going to make the quadrants, first and fourth. Now because of negativity, we move clockwise as well. नेगेटिव की वजह से हम क्लॉकवाइज भी जाएंगे और पॉजिटिव की वजह से हम एंटी क्लॉकवाइज दोनों क्वाड्रेंट्स में जाएंगे. बट वी नीड टू सी कि इसमें से कौन सा आंसर जो है डोमेन में लाई करता है और कौन सा लाई नहीं करता. तो अगर हम यहाँ देख लें तो थीटा माइनस यहाँ कर रहा हूँ, सही है, थीटा माइनस 33.69 degrees is equals to, the first answer will be anti-clockwise alpha. In the first quadrant is alpha, so this is 73.898. Now this is AS knowledge. In the fourth quadrant, it is 360 minus 73.898, which is 286.102. Right? And if because of negativity, I will rotate clockwise as well. So in the fourth quadrant, the answer would be minus alpha. So it's minus 73.898. But as soon as we rotate, we realized that our answers have to be between minus 33.69 and 326.31. So this is within the domain, this is within the domain, but this is not within the domain. So we need to see the revised domain for this. So we are going to cancel this out. But please, I've written it because at times this is considered and this is not considered. That would depend upon the value of basic angle. Let's suppose if the basic angle was 24 degrees. Then 24 would have been rejected because the domain starts from 33 point. Yes, because the domain, no, 24 would be accepted. Let's suppose that the basic angle was 24 degree and we would have written 24 over here. Then 360 minus 24 means 336 over here. And the another answer would be minus 24 degrees. So we would have accepted 24 degrees and minus 24 degrees, but 336 would have been outside the range, outside the domain. So we would have cancelled it. So this is not essential that the clockwise value will always be rejected. At times the clockwise will be accepted and one of the two answers from these two that I have given, one of these two answers will be rejected. That would depend upon the revised domain and the value of the basic angle. The revised domain is between minus 33.69 and 326.31, but the basic angle is 73.898. क्योंकि revised domain के अंदर basic angle जो है, basic angle को इस्तेमाल करते हुए जो answers हमने निकाले, वो 3 निकाले. 2 in the first and fourth quadrant in the anti-clockwise sense, and one answer was in the fourth quadrant minus basic angle clockwise sense. But out of those 3, we rejected one because that was outside the domain and we accepted the other 2. Now, once we have found the other 2 answers, we can simply find the value of theta, which is the ultimate objective of ours. And the theta is going to be in 1 decimal place. So 73.898 plus 33.69. So we have got 107.6 degrees. 107.588. It is 107.588. But now this is the last step, so we can round it off. 107.6 degrees. And if we are going to give the second answer, then 286.102 plus 33.69. And the answer is going to be 319.792. 319.792, which is going to round it off to, it will become 319.8 degrees. Correct to 1 decimal place. So these are the 2 final answers, and both of these will lie in the original domain. Because the answers of theta minus 33.69 lied in the revised domain, the values of theta will lie in the original domain. So we can check it out that 107.6 and 319.8 both lie between 0 and 360. Right? If we would have accepted minus 73.898 and we would have found theta, then that theta would also be outside the range of 0 to 360. outside the domain 0 to 360. So this is the final answer that I've given, and these are the two answers that are going to be the final answers in one decimal place. So I've completed this example as well. Please note it down and write clear and done, so we can end the class, because alhamdulillah we have been able to complete the trigonometry part, explanation part. Inshallah, I'll try to upload the file so you people can attempt the questions as well and bring queries in the next class. Inshallah, I'll try to upload the file tomorrow if I can. If I'm unable to, then I'll cover the questions myself in the next class. Inshallah, I'll update on the WhatsApp group whatever is feasible for me. Okay, okay. Because the difference between the two classes is very less. It's just a one-day difference. So at times I get very occupied on Fridays, and I'm unable to upload. So that is why I've told that might be I can upload or might be I cannot. So I'll see what I can do. If I can upload, then I'll let you know. Okay, then take a screenshot as well and let me know if you have copied and are you clear as well.
सर अगले क्लास में हम वो करेंगे ना, क्वेश्चंस करेंगे ना इसके।
एग्जैक्टली पास के क्वेश्चंस करेंगे मैं, लेकिन चाह रहा हूँ कि अगर मैंने फाइल अपलोड कर दी तो 2 4 5 क्वेश्चन 10 क्वेश्चन ट्राई करके लाओगे तो पता चलेगा कि जो इतना समझा है उसके कुछ हो भी रहा है या नहीं हो रहा।
हाँ ठीक है,
सही है, और फिर नहीं हो रहा होगा तो करवाना ही है मैंने तो। सही है ना?
ठीक है।
चले जी, ओके, अल्हम्दुलिल्लाह वी आर डन एंड वी हैव एंडेड द एक्सप्लेनेशन ऑफ ट्रिग्नोमेट्री। विद दैट टेक गुड केयर ऑफ योरसेल्फ, अपना बहुत सारा ख्याल रखें और मुझे दुआ में याद रखें। अस्सलाम वालेकुम व रहमतुल्लाहि व बरकातहू।